In this lesson, we're going to learn how to find a line of best fit using our graphing calculator. Now, a line of best fit is a trend line that actually shows the relationship between two quantities of data. We're used to the two quantities of data being called x and y, our independent variable and our dependent variable. So, make sure that you have your graphing calculator available, because we're going to talk about some things that are going to come up on the graphing calculator, such as the correlation coefficient. The correlation coefficient is going to be denoted by the letter R. It's going to tell you how closely the equation models the data. If your correlation coefficient is in the negatives, in this region right here, between 0 and -1, it's going to have a negative correlation. The closer it is to -1 or +1, the better the line is fitting the data. If your correlation coefficient is 0, then there is no correlation whatsoever. There's no relationship between the data. You can't say that as x increases, y is increasing strongly. And we'll take a look. Some good numbers to look for would be, for good correlations, 0.8, 0.9, anything in this area would be a good positive correlation. -0.9, -0.8, -1, those would all work. Anything in between those, change the color here, anything in between those numbers, say from -0.79 to +0.79, that's not going to be a very strong correlation. Probably a different type of function is going to fit that data. Right now we're just going to talk about linear regression is what it's called, linear regression. Linear means it's going to make a straight line. So you'll hear this referred to as linear regression. If you're using a TI calculator, you would want to Google linear regression in your Google toolbar and look for videos that will show you how to do linear regression with a TI calculator. So I might even Google linear regression TI-84 if that's what you're using, or TI-83. The steps are similar, but without a video instructing you, you would probably have a harder time on the TI trying to figure this out. So let's go right to an example. We're going to use a graphing calculator to find the equation of the line of best fit for the data at the right. So we've got recreation expenditures. So this could be, for instance, your cities or states' recreation expenditures for parks and recreation, anything that you did as a kid where it had to do with the city, that could be called recreation if you played city soccer. So those are the recreation expenditures. In 1993, $340 billion. Now, I don't know, this might be with respect to the actual whole United States. If we look here where it says source, statistical abstract of the United States. So this is how much money was spent in the United States in 1993 on recreation expenditures. We have $340 billion, not just $340. This billions is extremely important. $369 billion in 1994, so we're increasing. As the year increases, our expenditure amount increases. So we're going to see if there's a linear correlation to this data. Now, the equation, if you're looking at your graphing calculator, this is important to know. The equation of the line of best fit will be one of these forms. And this is true in either calculator that you're using. It's going to either be y equals ax plus b, where a is the slope and b is the y-intercept, or sometimes they write it backwards, y equals a plus bx. When given the choice, which we will always be given the choice, we are going to use this first equation because it looks most like what we're used to writing our equations in, which is slope-intercept form, y equals mx plus b. So let's get started. I'm going to open up my calculator screen here. And hopefully you can see that on the entire screen. Okay. From a main menu, we want to choose the statistics menu item. So you can scroll over to the statistics, press enter, or you can press the number that's associated with that item. Now, in list 1, we're going to put our independent variable. Our independent variable, let's see here, our independent variable is going to be our time. I did not even spell that correctly. Independent variable. I'm not going to have room. And dollar spent will be our dependent variable. So this, in essence, is our X, and our dollars in billions will be our Y. Now, when we enter data, if we were to make a chart, would we say that time starts at 0, and then we would go up maybe by centuries or millennium? You know, I'm not sure how you would do that. I certainly would not go back to the year 0. So I would not go back to the year 0. So my starting point here, since it includes information from 1993 to 2000, I would probably, in this case, say that 1993 corresponds to 0, and 1994 corresponds to 1, and 1995 corresponds to 2, and 3, and 4, and 5, and 6, and 7. Now we can say, because that's our starting point of our data, we can say 0, 1, 2, 3, 4, etc. And then going up, we would, of course, go up by our billions. So I would start with 0 billion. I would not change this numerical value. So my numerical input would be 340. So that I would show a y-intercept. Our initial value would be $340 billion. And then our data is going to, you know, maybe increase there like that. And then you're used to just drawing a line that goes through the data and saying, yep, that's my line of best fit. Well, we're going to come up with the line of best fit that is truly accurate. So let's go back to our calculator. We're going to enter into list 1. List 1 will be our X values. So we're going to enter 0, and then 1, 2, 3, 4, 5, 6, 7. So I have 8 values that I've entered in, 0 through 7. The dollars that corresponds to 0 will be 340. And I double check to make sure I haven't made any mistakes, because if you make a mistake entering your data, you will not get the correct equation. 369 for 1994. When X is 2, which is 1995, we have 402, and then 430, 457, 489, 527, and 574. So we have our data in, and now we're going to hit graph. Get my calculator there. So we'll hit graph, and then graph 1, and it will graph the data for you. So you can see all your data points. So as our independent variable increases, which is our X value, our Y value is also getting larger. Now we simply hit calculate, because we want to calculate our linear regression. Well, linear regression is y equals mx to the first power plus b. So we're going to choose F2. That's our linear regression. And that gives us our 2 choices that I had spoken about earlier, ax plus b or a plus bx. We want the first choice, which is ax plus b. We always want to choose that point or that form. Now, this is very interesting here. We have A equals 32.3 repeating, B equals 335.3 repeating, and here's our R value. This is our correlation coefficient. That correlation coefficient, so our correlation coefficient is very, very close to 1, 0.996. So what we need to do now is we found our equation of our line of best fit. We just need to write this down. Our A value is 32.3 repeating, and our B value is 335.3 repeating. So remember, we have Y equals AX plus B. Looking at our calculator, our A value is 32.3 repeating, and our B value, let me pull that back up, is 335.3 repeating. And there's our equation of our line of best fit. Okay, let's try another. We'll do that in the next video. This video is already about 11 minutes long, so the next video we'll do another problem. We've got a couple more problems to do to give you some experience so that you're good to go for your homework.